All right, so starting with proving lines parallel. Kind of a continuation of what we were doing last week. Only this week we're going to, and I should say more of the last lesson there. The last lesson we had things, we knew lines were parallel, so then what did we know from that? Well, now we're going to be going the other way. What things do we need to know that we can then say that, hey, the lines are parallel? So starting here with the corresponding angles postulate, if you think back, this is where we go pretty much if the lines are parallel. So if parallel, then corresponding angles are congruent. So if the lines are parallel, then we know corresponding angles are congruent. That was that corresponding angles postulate. So that's what we did the last time. So now we're going to get the second postulate of this chapter, which is going to be the converse of corresponding angles postulate. So if you think about it, when we're doing conditionals and converses, we had conditionals, if then, the converses, then switched the if and the then, so they were going the other way around. So this is saying now, hey, if we have corresponding angles that are congruent, then the two lines will be parallel. So it's saying it the other way. So if we know, say, 1 and 5 are congruent, then we know that L and M are parallel. Converse of the alternate interior angles theorem. So if the alternate interior angles are congruent, then the two lines are parallel. So if we know, say, 4 and 6 are congruent, then we know L and M are parallel. And lastly here, theorem 3.6, which is the converse of the same side interior angles theorem. So if same side interior angles are supplementary, then we know the two lines are parallel. So if we go back up here, if we know, say, 4 and 5 are supplementary, then we know L and M are parallel. And that's what we're dealing with. So another way we can prove things is with a flow proof. So flow proof is going to show how things go from kind of our thinking process of, okay, what are we given? What else can we kind of see there? Well, what does that mean? Well, it means this. Okay, so now that we know that, then what does it mean? Well, it means this. And we just flow along. So our steps are going to go in the boxes. The reasons go underneath them. So here, if we're going to prove that theorem 3.5, we would start with angles 1 and 2 are congruent, and that's our given. Well, looking at this, we can also see that 1 and 3 are going to be vertical angles, and we know that vertical angles are congruent, so we know 1 and 3 are congruent. So, knowing both of these things, that leads to our next thought of 3 and 2 are going to be congruent by that transitive property. So 1 goes to 2, 1 goes to 3, so therefore 2 and 3 are together. So, knowing that, if we know 3 and 2 are congruent, those are corresponding angles. Well, then we know the lines are parallel by that corresponding angles postulate, that postulate 3-2. Right? So, still starting with the given, we can also include anything else that we can just look at and know, and then we build. Okay, so knowing this stuff, we know this. Knowing this, we know this. That's how flow proofs go. Typically, we don't do those. We also won't do paragraph proofs a whole lot. Mainly, we'll stick to the 2-column proofs, but this is just another way that you could do stuff. So looking at this diagram, which of any must be parallel if we know 1 and 2 are congruent? So if we come over here and we're going to make our marks of knowing, okay, this one and this one are congruent. So in this case, DK is going to act as our transversal. So the one that they both touch is the transversal. And then the two lines that each one touches will be our two parallel lines. So DK touches both, so DE is going to be parallel then to CK. And that's because these end up being alternate interior angles. They're alternate of our transversal. They're on opposite sides inside the parallel lines. So this is going to be that theorem 3-5. So because we know the alternate interior angles are congruent, we know that DE and CK are going to be congruent. Now, you may ask, well, what about the other two sets of lines? So EC and DK. Well, our angles 1 and 2 don't touch anything with EC, so knowing these two angles are congruent can't relate anything to EC. What we would need to know is something involving 4 and 3 or 2 and 3. We need to have more information or before we could say that DK and EC are congruent or parallel. They might be, but right now we don't know enough. All we know is with 1 and 2 being congruent, that ED, CK can be congruent. So with that being said, we have theorem 3.7, which is the converse of alternate exterior angles theorem. So again, converse, so here we're saying that if we have alternate exterior angles that are congruent, then we know the two lines are parallel. So 1 and 7, which are not on this diagram, but on the next diagram. So 1 and 7 here, if those two, I'm still on the screen, sorry. So 1 and 7, if those two are congruent, then we know that the lines L and M are parallel. And then we have theorem 3.8, the converse of the same side exterior angles theorem. So same side exterior angles are supplementary, then we know the lines are parallel. So if we're looking at, say, 2 and 7 or 1 and 8, if we know those are supplementary, then we know the lines L and M are parallel. And to prove that, we're going to do a two-column proof. And this is going to take 4 steps. So step 1, 2, 3, and 4. 1, 2, 3, and 4. All right, so first step always is your given. So we write angle 1 is congruent to angle 7, and our reason is given. That's always your first step. And then your next step is we're going to write the proof in, which is L is parallel to M. So we're always going to end with our proof, start with our given. So now we're going to fill in what we know. Well, one habit you want to get into is marking in those little tick marks to know what's congruent, what have you proven so far. So we know that 1 and 7 are congruent. So I'm going to draw the marks to show that those two angles are congruent. So now we need to make some sort of tie between 1 and 7 that'll lead us to show that those angles cause it to be congruent. So something we've proved already is corresponding angles are congruent. So we can do this 2 different ways. We can either look at getting 5 in here, or we can look at getting 3 in here. Either way will work, but what they're going to do is, let's say angle 3 is congruent to angle 1 because these are vertical angles. So we're going to go angle 1 is congruent to angle 3 by vertical angles. So 1 and 3 are something that we can easily say are vertical angles. We could have done the same thing with 5 and said 5 and 7 are vertical angles. Either way works there. But what that's going to lead to is we have 1 congruent to 7 and 1 congruent to 3. So angle 1 is congruent, no, angle 7, sorry, is congruent to angle 3 by the transitive property. So 7's to 1, 3 to 1, so we can just make that jump and go 7 and 3 are congruent together. So we now have corresponding angles, 7 and 3, that are congruent. If we know corresponding angles are congruent, we know the lines are parallel by that postulate 3-2. So that's why exterior angles, alternate exterior angles will be congruent. So proven 3.7. Now we can also do problems like this. Now this is going to have, we're going to try to find what value of x that'll make L and M be parallel if we know measure of angle 2 is 40 and the measure of angle 6 is 2x plus 6. So if we look up here, we're dealing with angle 2 and angle 6. We want them to be what in order to have parallel lines? Well, those are corresponding angles. So corresponding angles, if they are congruent, then we know the lines are parallel. So we're going to set these equal to each other. So 40 equals 2x plus 6. Now we just have an algebra equation that we can solve. So subtract the 6 over. So 34 equals 2x. And divide by 2. X is going to equal 17. And we're going to put degrees there. Actually, we probably don't need the degrees because we're just solving for x. We're not finding the angle. So think about what properties do you know based off of what type of angles they are. And then we go from there. Now, lastly here, we have 2 construction workers are painting lines for an angled parking space, or for angled parking spaces. The first worker paints a line so that the measure of angle 2 equals 60 degrees, and the second worker paints a line so that the measure of angle 8 is 60 degrees. Explain why they're going to be parallel. Well, if we draw this out here's our transversal. And then we're going to have two parallel lines cutting through. So we have angles 1, 2, 3, and 4, 5, 6, 7, and 8. So we're looking at angle 2 being 60 and angle 8 being 60. So why are these parallel? Well, let's look. If we know this angle and this angle are congruent, these are what type of angles? Well, they're along our transversal here. So they're on opposite sides of it, and we have our parallel lines that we're trying to show. They're on the inside of those. So these are alternate interior angles, and we know if alternate interior angles are congruent by theorem 3.5, then we know that the lines are parallel. So that is it for this lesson. Let me know if you have any questions. Otherwise, until next time, we'll talk to you later.